Welcome, ladies and gentlemen. Today we're going to be talking about factoring polynomials. So most of this is going to be a review because we factored in Unit 4, but there are going to be a couple new things that we're going to be looking for, all right? So your learning target today, the newest thing that we're going to be talking about the most is we're going to be able to factor a perfect cube. All right, so make sure you get this learning target down for me, please. Now factoring, remember you guys, you don't have to write this down, but it's just taking a quadratic or a problem and breaking it up into multiple pieces, all right? Types of factoring, you don't have to write this down either, all right? It's greatest common factor. That's a big one that we're going to have to look at these next few days. That's going to come up a lot in most of our problems. We're going to have to do that before we can factor another way. So we have to be definitely looking for that greatest common factor throughout our work this week. Grouping, trinomials, or that AC method, difference of perfect squares, and then our new one that we're going to talk about is sum and difference of perfect cubes. Okay, that's going to be our big hitter today. All right, now I know you guys, we've done a lot of factoring with trinomials, but I'm going to do one example. I'd like you guys to get this in your notes because our trinomials are going to look a little bit different. If you see this on the top in red, we are used to that x squared plus bx plus c, but now we're going to start seeing some like x to the fourth, then we're going to have x squared plus c, or x to the sixth, okay, x to the third. Things are going to be breaking down a little bit different than we have seen them before. So just things to be aware of. Now I want this one in your notes. When we're factoring this trinomial, the first thing we're going to be looking for is that greatest common factor. And in this one we have one. Our greatest common factor in all three of these is 4x squared. So that's going to be taken out first. So I'm going to put that out in front. I'm going to get a 4x squared, and I'm going to be left with x to the fourth minus 5x squared plus 6. So that's what we have here. Now remember you guys, this right here, this 4x squared, that's our super annoying little brother or sister. We can't forget about it at the end in our answer, but while we're working through everything else, we're just going to put it to the side, but we have to remember to put it in our answer in the end. So now if we look at our trinomial, we're going to use our AC method. So we're going to take A times C has to add up to B. So I have 1 times 6, which is just 6. And I need two factors that add up to equal -5. So if I have a positive number, I'm going to want to use two negative numbers to get that -5. -3 and -2 work. Now, this is where this one's going to be a little bit different than what we're used to. We're plugging these two numbers in for this -5x squared. So when I rewrite this problem, I'm going to have x to the fourth minus 3, and it's not just going to be x, you guys. This was an x squared, so I have to put x squared, minus 2x squared plus 6. So we have to make sure we're watching our exponents now. Once we get here, we're going to treat it like a grouping problem, break it into two parts. Greatest common factor in my first one is x squared, so take that out. Put that in front, x squared, we're left with x squared minus 3. My second one, I can take out a -2 out of both of these. Put that down here, -2. I'm left with x squared minus 3. These are the same, which is really important, which we need for our answer. So that's going to be one of our factors. So one of my factors is going to be x squared minus 3. My second one is going to be what's left over here. So I get x squared minus 2. Now I'm checking, they're both x squared, so there's a possibility I can use perfect squares. They're both subtraction, but 2 and 3 are not perfect squares, so we can't break that down anymore. But we can't forget, over here, that super little annoying brother or sister has to go out in front. So I have 4x squared out in front. This whole thing, ladies and gentlemen, that's going to be my answer. So you're going to be seeing some of these in your assignment where you're going to have to take out a greatest common factor, and it's not just x squared that we're working with when we're solving our trinomials. Alright, our next one, I know we've done lots of perfect squares. I just want to bring this up to you guys right now. This doesn't always have to be 2. In this case it's 4, it can be 6, it can be 8. It has to be an even number. but it can be any of those. So 2, 4, 6, 8, 10, any even number. Then we're going to break this down into our 2, 1 plus, 1 minus. Perfect square of 16 is 4. Perfect square of 81 is 9. So those are our numbers. But now that I have x to the 4th, we're just cutting that in half. So half of 4 is 2. So now instead of just putting x, I have to put x squared in both of these. Okay? So just a little refresher there. You're going to be seeing some of these where you have to think about what you're going to put for your x values. All right. That's old stuff. Now we're going to get into our new stuff. This also has to be written in your notes, you guys. You're going to want a list of your perfect cubes somewhere handy where you can get them out, use them a lot. So 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed is 216, 7 cubed is 343, 8 cubed is 512, 9 cubed is 729, and 10 cubed is 1,000. So please do me a favor, get this list down somewhere because you're going to want to use it as a reference when we're doing our perfect cubes. All right, I have 2 more examples for you guys. Have to be written down. This one has to be written down. Everything on this slide has to be written down. It's the sum of 2 cubes. Okay, so we're talking about addition. This is going to look different than what we've done. The biggest thing, you guys, is we're going to be using this equation right here. So make sure you have that highlighted. And that both things have to be written as cubes. Alright, so I have an x cubed here. Now I have to rewrite 64 as a perfect cube. So if I looked at my list of cubes you should have written down, we can rewrite this as x cubed plus 4 cubed, because 4 cubed equals 64. That's the first thing we have to do, is rewrite everything as a cube. Once we do that, we're just going to identify what our a and b are so we can plug it into this equation. My a is going to be that first thing here, so my a is x. And my b is what's going to be cubed in my second part, so that's 4. Once I know that, I'm just going to plug everything I know into this equation. So here, this is going to equal, instead of a, I'm going to put x, plus instead of b, I'm going to put 4. Now I'm going to move on to the second parenthesis. Instead of a, I'm going to put x squared minus, now I have ab, so I have x times 4 plus my b squared, so that's going to be 4 squared. Now I'm going to simplify this second half. So I'm going to rewrite my problem. The first part's going to stay the same. I have x plus 4. Second part, I can't simplify x squared, so that stays. We usually write this different, so we're going to do it, so it's going to be minus 4x. And then we can simplify 4 squared, which is 16. So we have plus 16 here. This is my final answer, ladies and gentlemen. So when you're doing this, biggest thing is to make sure that your cubes are written as cubes. Okay, and then you're just plugging in a and b into your equation. Now we're going to do one more. This was the sum of 2 cubes. This next example is going to be the difference of 2 cubes. So please make sure, again, you guys, you get this all written down, because our sum and difference are different equations. We're going to be using this one a lot. Okay, first thing again, you guys, everything has to be written as a cube. If we look at this one, I have an 8 out in front. That has to be written as a cube. So I'm rewriting this. I'm going to put it in parentheses because it's all to the cube. Now, if I looked at my list, 8 can be written as 2 cubes. So I'm going to have 2w. Both the 2 and w are being cubed. Minus 27 has to be written as a cube, so that's going to be written as 3 cubed. Once I get here, I need to identify my a and my b. My a on this one is 2 things. It's 2w. My b on this one is just 3. Once I have those identified, I'm going to come in here, plug it into this equation. So this is going to equal, my a is 2w minus my b, which is 3. Now here, the second part, I'm going to start off in a bracket because I have to have a squared. But my a now, you guys, is two things. It's 2w. So this has to be in parentheses, 2w squared. Then I have plus a times b, so I have 2w times 3 plus my b squared, so I have 3 squared. Once I'm done here, I'm going to break this apart and I'm going to simplify it. Okay? Simplify what's in the second part. So the first part's staying the same, so I have my 2w minus 3. Second part I'm breaking down. Now this squared means it's 2 times, so it's 2w times 2w. If I break that down, I have 2 times 2 is 4, and I have 2w, so it's w squared. That's how I want that written, you guys. Next part here, I can simplify this. 2 times 3 is 6, so I have plus 6w. And at the end, I have that 6 squared, so it's just plus 9. And this is going to be my final answer here. Okay, so biggest thing, making sure things are written as cubes, identifying your A and B, and then we're just plugging it in. Okay, make sure you had this example written down, please. Now you guys can write this down if you want. You don't have to write this part down, but we are going to be working with factoring a lot. So the first thing we always have to look for is that greatest common factor. Okay, if it can't be greatest common factor, then we're going to move on. We're going to do grouping, that's 4 terms. Our AC method, that's our 3 terms, our trinomial. And then we have difference in sum of cubes, and we also have what? Difference of squares. Sorry, that one's not on there. Okay, so make sure that we're looking for all of these things. Alright, ladies and gentlemen, that is all I have for you. I hope you all have a fabulous day, and I will be seeing you soon. Bye!